Imagine a time, back in 1977. The world was a very different place. Yet, from this moment in human history, we launched two of our most ambitious explorers. Not people, but machines. These were the Voyager 1 and Voyager 2 probes. Their initial mission was to give us a grand tour of the gas giants, Jupiter, Saturn, Uranus, and Neptune. They were our robotic eyes, sent to witness worlds of swirling storms and icy rings. Their journey was a triumph of human ingenuity, sending back pictures and data that forever changed our view of our own cosmic neighborhood. They showed us volcanoes on Jupiter's moon Io and geysers on Neptune's moon Triton, revealing a solar system far more active and dynamic than we had ever dreamed. But their mission didn't end there. After completing their tour of the planets, the Voyager probes just kept going. They were traveling faster than any object we had ever sent into space, hurtling towards an unseen frontier. They became our first emissaries to the stars, carrying with them a golden record. This record is a time capsule, a message in a bottle cast into the cosmic ocean. It contains sounds and images selected to portray the diversity of life and culture on Earth. It is a greeting for any intelligent life that might one day find these silent travelers. For nearly 5 decades, these probes have been our silent sentinels, pushing ever outward, venturing into the great unknown that lies beyond the familiar lights of our planets. Today, on August 5th, 2025, we celebrate their continued journey. These venerable machines are now more than 24 billion kilometers from home, so far away that a command sent from Earth takes over 22 hours to reach them. They have traveled farther and longer than any other human-made object in history. They have become a testament to our enduring curiosity, a symbol of our desire to understand our place in the universe. Their mission has evolved from one of planetary exploration to one of interstellar discovery. They are no longer just looking at our neighbors. They are now reporting back from the boundary of our home, the very edge of the sun's influence, a place we are only just beginning to understand. The data they send back is faint, a whisper across the vast emptiness of space, but it is revolutionary. Each packet of information challenges our theories and opens up new mysteries. These probes, built with technology from the 1970s, are still making front-page news in 2025. They are rewriting our textbooks from the darkness between the stars. Their longevity is a miracle of engineering, and their discoveries are a gift to all of humanity. They remind us that exploration is not just about the destination, but about the journey itself and the incredible, unexpected things we learn along the way. They are humanity's longest-running adventure story, and the next chapter is always a surprise. To understand the Voyager probe's latest discovery, we must first understand where they are. They are traveling through a region called the heliopause. Think of our sun not just as a source of light and heat, but as the center of a giant protective bubble. This bubble is called the heliosphere, and it is formed by a constant stream of charged particles flowing outward from the sun. We call this stream the solar wind. It travels at supersonic speeds, pushing back against the material that fills the space between stars, which we call the interstellar medium. The heliosphere is our home, a vast cosmic territory carved out by our star's influence, shielding us from harsh galactic radiation. The heliopause is the very edge of this bubble. It is the boundary where the sun's solar wind, having traveled billions of kilometers, finally becomes too weak to push any further. At this point, it collides with the interstellar medium. This is the ultimate frontier of our solar system. For decades, scientists could only theorize about what this boundary would be like. Was it a smooth, gentle transition? Or was it a chaotic, turbulent place? It was a complete mystery, a line on a map that no one had ever crossed. Voyager 1 crossed this boundary in 2012, followed by Voyager 2 in 2018, officially becoming the first human objects to enter interstellar space. Crossing the heliopause is a monumental achievement. It means leaving the sun's direct influence behind and entering the galaxy proper. Inside the heliosphere, all the particles and magnetic fields originate from our sun. But outside, in interstellar space, everything is different. The particles, the radiation, and the magnetic fields belong to the vast Milky Way galaxy. The heliopause is therefore the dividing line between what is ours, part of the solar system, and what is theirs, part of the galactic neighborhood. The Voyager probes act as our scouts, sending back the first direct measurements from this unexplored territory, telling us what it's truly like on the other side. The significance of this boundary cannot be overstated. It is the skin of our solar system, protecting the planets within. Without the heliosphere, Earth would be bombarded by a much higher level of high-energy cosmic rays, which could have profound effects on our atmosphere, and even on the evolution of life itself. Understanding the nature of the heliopause, how strong it is, how it interacts with the galaxy, is crucial for understanding our own environment. The Voyager's journey across this boundary is like the first time ancient sailors left the sight of land. They are charting the unknown waters of the interstellar sea, and their findings are helping us build a map of our place in the cosmos. As the Voyager probes pushed through the heliopause, they sent back data that was truly shocking. They detected a region of incredibly high temperatures. Scientists are reporting temperatures between 30,000 and 50,000 Kelvin. To put that in perspective, the surface of our Sun is about 5,800 Kelvin. This region is therefore many times hotter than the Sun's surface. This has led some to nickname this boundary a wall of fire or a firewall. It paints a dramatic picture of a fiery barrier surrounding our solar system. But this name, while exciting, is also very misleading. This region is not made of actual fire, and it is not burning in any traditional sense. So, if it's not fire, what is it? The extreme temperatures are not due to heat as we experience it on Earth. Instead, they are a measure of the energy of individual particles. The firewall is made of a very thin, spread-out gas called plasma. The particles in this plasma are super energetic, zipping around at tremendous speeds, which is why temperature readings are so high. However, the key is that these particles are extremely sparse. There are very few of them in any given amount of space. The density is so incredibly low that you could fly a spaceship right through it, and it would barely notice. This is exactly what happened to the Voyager probes. Think of it this way. Temperature measures the speed of particles, while heat is about the transfer of energy. You can have very hot particles, but if there are not many of them, they cannot transfer much heat. It's like the difference between being hit by a single fast-moving grain of sand versus being hit by a whole wave of sand at the beach. The single grain is moving quickly, high temperature, but it won't hurt you because it's just one tiny particle. The wave, however, has countless grains, high density, and can knock you over. The firewall is like a few individual super-fast grains of sand in a vast, empty space. This discovery forces us to rethink how energy behaves at the edge of our solar system. The fact that the Voyager probes survived their passage through this super-hot region is proof that temperature and heat are two very different things in the vacuum of space. The firewall is not a destructive barrier but a fascinating physical phenomenon. It is a place where the sun's wind crashes into the galaxy, creating a zone of superheated, low-density plasma. It's a cosmic-scale physics lesson, teaching us about the complex and often counterintuitive nature of the universe that exists just beyond our doorstep. Beyond the astonishing temperatures, the Voyager probes discovered something else that has left scientists scratching their heads. This finding concerns something invisible but incredibly powerful: magnetic fields. Before the probes crossed the heliopause, scientists had a clear prediction. They believed that the magnetic field inside our solar system's bubble, which is generated by the sun, would be very different from the magnetic field of the interstellar medium outside. They expected to see a dramatic shift, a clear separation between the sun's magnetic influence and the galaxy's magnetic field. It seemed logical that these two distinct environments would have their own unconnected magnetic signatures. But that is not what Voyager found. As both Voyager 1 and Voyager 2 punched through the heliopause, they measured the magnetic fields on both sides of the boundary. To everyone's surprise, the magnetic field just outside the heliosphere was almost perfectly aligned with the magnetic field just inside it. They were pointing in the same direction, as if they were connected. This was completely unexpected. It's like finding that the currents of a small bay flow in the exact same direction as the currents of the vast open ocean. It suggests a much deeper and more mysterious connection between our solar system and its galactic surroundings than anyone had ever imagined. This discovery has profound implications. It suggests that the sun's magnetic field somehow influences the galactic magnetic field just outside our heliosphere. Or perhaps the other way around. The heliopause may not be a simple wall separating two regions, but a much more complex, porous boundary, where the two magnetic fields interact and align. This finding challenges our fundamental models of how stars like our Sun interact with their interstellar environment. It opens up a whole new area of research, prompting scientists to ask new questions. How does this connection work? How far out does this alignment extend? What does it tell us about the structure of the magnetic fields that crisscross our entire galaxy? The Voyager mission continues to be a journey of pure discovery. We sent these probes out to look at planets, and now they are fundamentally changing our understanding of our place in the Milky Way. They have shown us that even after nearly 50 years of travel, there are still great surprises waiting in the darkness. The discovery of the aligned magnetic fields, along with the firewall, proves that we have so much more to learn about the universe. The Voyager probes are not just old machines. They are our guides, leading us into a new era of cosmic understanding, one faint signal at a time. Their legacy is a reminder that the universe is always more intricate and more wonderful than we can predict.